HSRP configuration. Addressing table R1 with 3 interfaces. This is R1 with 3 interfaces. R2 3 interfaces. R3 3 interfaces. Internet. Okay, this is internet. HSRP virtual gateway is virtual. Switch 1, switch 3, PCA, PCB. Switch 1, switch 3, PCA, PCB. And server on internet. This server. You will learn how to configure hot standby router protocol HSRP to provide redundant default gateway devices to hosts on LANs. After configuring HSRP, you will test the configuration to verify that hosts are able to use the redundant default gateway if the current gateway device becomes unavailable. Configure an HSRP active router, configure an HSRP standby router, verify the operation. Spanning tree protocol provides loop-free redundancy between switches within a LAN. However, it does not provide redundant default gateways for end-user devices within the network if a gateway router fails. Field Hop Redundancy Protocols (FHRPs) provide redundant default gateways for end devices with no additional end-user configuration necessary. By using a FHRP, 2 or more routers can share the same virtual IP address and MAC address and can act as a single virtual router. Hosts on the network are configured with a shared IP address as their default gateway. In this packet tracer activity, you will configure Cisco's Hot Standby Router Protocol, HSRP, which is an FHRP. You will configure HSRP on routers R1 and R3, okay, on these 2 routers, which serve the default gateways for the hosts on LAN 1 and LAN 2, okay, LAN 1 and LAN 2. When you configure HSRP, you will create a virtual gateway that uses the same default gateway address for hosts in both LANs. If one gateway router becomes unavailable, the second router will take over using the same default gateway address that was used by the first router. Because the hosts on the LANs are configured with the IP address of the virtual gateway as the default gateway, the host will regain connectivity to remote networks after HSRP activates the remaining router. Verify connectivity. Trace the path to the web server from PCA. Go to PCA, trace the path from PCA to web server. Use this command tracer 209.165.200.226, the IP address of the web server. Go to PCA and desktop command prompt. Tracer 209.165.200.226. Okay, 4 hops. First hop is R1, 192.168.1.1 is R1. Second hop is R2, 10.1.1.2, R2, 10.1.1.2. Third hop is Internet, 10.100.102, 10, 100, 102. And the last hop is the web server. The web server is this. Which devices are on the path from PCA to the web server? Use the addressing table to determine the device names. Okay, R1, R2, Internet, and web server. Trace the path to web server from PCB. Repeat the process from PCB. Go to PCB, tracer, the IP address of the server to 9165.200.226. Okay, 4 hops. First hop is R3, 192.168.1.3. Second hop is R2. Third hop is Internet. Third hop is Internet 10, 100, 102. And fourth hop, the server. This server. Which devices are on the path from PCB to the web server? R3, R2, Internet, and the web server. Observe the network behavior when R3 becomes unavailable. Select the Delete tool from Packet Tracer toolbar and delete the link between R3 and S3. Okay, delete this link. Okay, delete. This is the connection between gigabit 00 to gigabit 02. 00 to gigabit 02. Delete. Okay. Select tool. Open a command prompt on PCB, execute tracer command with the web server as the destination. Go to PCB, repeat the previous tracer, the IP address of the web server, enter. Compare the current output with the output of the command from step 2. What are the results? Okay, request timeout. Request timeout. Control C to stop this. Okay, the tracer command cannot determine the path to the web server because the path has been broken. Okay, review PCB, ipconfig, and you know the default gateway for PCB is 192.168.1.3. Is 192.168.1.3 is gigabit 00 on R3. Okay, gigabit 00 on R3. This is gigabit 01. This is gigabit 02, and gigabit 00 was disconnected from the switch. So this default gateway is not available for PCB. So that's why the tracer is not working. Click the connections, copper straight through. Click on S3, gigabit 02, R3 gigabit 00. Connections straight through, switch 3 gigabit 02, R3 gigabit 00. After the link lights on the connection are both green, test the connection by pinning the web server. The ping should be successful. Okay, go to PCB. But wait a moment for the green indicator. Okay, go to PCB, ping to the server 209.165.200.226. Success. Okay, gigabit 00 is the default gateway for PCB. 192.168.1.3. 192.168.1.3. Okay, and configure HSRP active and standby routers. Configure HSRP on R1. Configure HSRP on gigabit 01 LAN interface on R1. Okay, on this interface, gigabit 01 on R1. Okay, the LAN interface. Enter the interface on R1. Enter enable configure terminal interface gigabit 01. Specify the HSRP protocol version number. The most recent version is version 2. Standby version 1 only supports IPv4. Okay, standby version 2. Configure the IP address of the virtual gateway or virtual default gateway. This address must be configured on any host that requires the services of the default gateway. It replaces the physical interface address of the router that has been previously configured on the hosts. Multiple instances of HSRP can be configured on a router. You must specify the HSRP group number to identify the virtual interface between routers in a HSRP group. This number must be consistent between the routers in the group. The group number for this configuration is 1. Okay, standby group 1 and set the virtual IP address. Standby group 1 and set the virtual IP address 192.168.1.254. Enter. Okay, and remember the LAN network. Okay, PCA is look at the LAN interface of R1 is gigabit 01, gigabit 01. PCA is 192.168.1.101. PCB 192.168.1.103. So this virtual IP default gateway should be placed on the same network like PCA, PCB, and LAN interface on R1. Okay, should be placed on the same network. Enter and designate the active router for HSRP group. It is the router that will be used as the gateway device unless it fails or the path it becomes inactive or unusable. Specify the priority for the router interface. The default value is 100. A higher value will determine which router is the active router. If the priorities on the routers in the HSRP group are the same, then the router with the highest configured IP address will become the active router. Okay, set the priority, standby 1, priority 150. Okay, The default is 100. I'm using 150. Group 1. R1 will operate as the active router, and traffic from two LANs will use it as the default gateway. If it is desirable, then the active router resumes that role when it becomes available again. Configure it to preempt the service of the standby router. The active router will take over the gateway role when it becomes operable again. Okay, and set preempt. Standby preempt. Exit. What will the HSRP priority of R3 be when it is added to HSRP group 1? Okay, if R1 will be the active router with a priority of 150, R3 will be the standby router, and R3 should have a lower priority, in this case the default 100. Configure HSRP on R3. Configure R3 as the standby router. Configure R3 interface that is connected to LAN 2 gigabit 00. Gigabit 00 on R3, gigabit 00, 192.168.1.3. Okay, go to R3. Remember gigabit 00. Enter enable configure terminal interface gigabit 00. Repeat only steps 1B and 1C. 1B, set the version, stand by version 2, and 1C, the same virtual IP, standby group 1, virtual IP 192.168.1.254. Okay, be careful, it should be the same virtual IP on R1 and R3. Avoid this because the default priority is 100. So R3 will use 100 as the priority. And if you want, configure preempt on R3. Will work anyway, but for this lab is not recommended. Enter. Verify HSRP by issuing the show standby command on R1 and R3. Verify the values for HSRP role, group, virtual IP address of the gateway, preemption, and priority. Note that HSRP also identifies the active and standby router IP address of the group. Okay, go to R1 and show standby. Enter. Okay, on gigabit 01, the group is 1, version 2, the state is active router because the priority is higher than R3, R1, priority 150. Okay, virtual IP address, virtual MAC address, preemption enabled, active router is local. The standby router is R3. 192.168.1.3. Standby router is R3. 192.168.1.3. Okay. R3 is standby, R1 active. Okay, and go to R3 and show standby. gigabit 00, remember, configure on gigabit 00 the LAN interface. Group 1 version 2 state standby. R3 is standby. R1 is active. The same virtual IP address, MAC address. Okay, compare the MAC addresses. Is this and the same MAC address? You can verify this. No preemption disabled. Active router is R1, 192.168.1.1. Okay, on R1, 192.168.1.1. Okay, the active router is R1, the standby router is R3. Okay, priority by default 100. Which router is the active router? R1 active router. What is the MAC address for the virtual IP address? This is the MAC address. The same on R3. 00009F F001. Okay, this is the virtual IP address and its virtual MAC address. Virtual IP address and virtual MAC address. What is the IP address and priority of the standby router? R3 is the standby router. The IP address is this. 192.168.1.3, standby router R3, 192.168.1.3, and the priority on R3 by default is 100. Show standby brief command on R1 and R3 to view an HSRP status summary. Okay, show standby brief on R1 and R3. Go to R1, show standby brief. Okay. And on R3, show standby brief. Okay, on R1, the interface gigabit 01, group 1, priority 150, P indicates configured to preempt, state active router, the active router is local, the standby router is R3, virtual IP is this, 254. On R3, the interface gigabit 00, group 1, priority by default 100, no preemption, state standby, active R1, the standby router is the local router, virtual IP 254. Change the default gateway address for PCA and PCB, S1 and S3. Okay, for example, on PCB, remember ipconfig. The default gateway for IPv4 is 1.3 is R3, and from PCA, ipconfig. For PCA, the default gateway is 192.168.1.1 is R1. So change for use the virtual default gateway for PCA, PCC, S1, and S3. Which address should you use? The virtual IP address, 192.168.1.254. PCA, 192.168.1.254. PCB, 192.168.1.254. Switch S1. Enter, enable, show running config, space. The default gateway is 192.168.1.1. And copy, configure terminal, paste IP default gateway 192.168.1.254 and switch S3, enter, enable, configure terminal, show running config to verify, space is 13, configure terminal, paste IP default gateway, change to 254, and verify new settings, issue a ping from both PCA and PCB to web server. Are the pings successful? Okay, on PCA, command prompt, ipconfig again, up arrow to repeat the previous command, default gateway 254, pings to the server IP address is ping 209.165.200.226, enter, success, control PCB, command prompt, ipconfig 192.168.1.254, ping to the web server 209.165.200.226, success. Are the pings successful? Yes. Observe HSRP operation. Make the active router become unavailable. Open a command prompt on PCB and enter the command tracer 209.165.200.226. Does the path differ from the path used before HSRP was configured? Okay, and look at this. Be careful. Open a command prompt on PCB. Okay, PCB. Repeat the tracer to the server, tracer 209.165, enter. Does the path differ from the path used before HSRP was configured? Okay, this is R1, this is R2, this is internet, and this is the server. Okay, this is R1, 192.168.1.1. This is R1, 192.168.1.1. 192 R1, 192.168.1.1. And compare with the previous tracer. The hop one was R3, 192.168.1.3. But now the hop one is R1. That is the difference. So the answer is yes, the path now passes through R1 instead of R3. Break the link to R1. Select the Delete tool from Packet Tracer toolbar and delete the cable that connects R1 to S1. Immediately return to PCB and execute tracer 209.165.200.226 command again. Observe the output of the command until the command completes execution. You may need to repeat the trace to see the full path. Okay, and delete the connection from R1 to S1. Delete this connection between gigabit 01 and gigabit 02. Delete. Okay, now R1 is unavailable for the LAN. Go to PCB. Repeat up arrow to repeat the previous command, tracer 209.165.200.226. How was this trace different from the previous trace? Now, it's using R3. When R1 is the active router is available, PCB uses R1. But when R1 is unavailable, PCB uses R3. At first, the trace timeout. Eventually, the trace went through R3, R2, the internet. R3 was used as the first hop gateway in this trace instead of R1. HSRP undergoes a process to determine which router should take over when the active router becomes unavailable. This process takes time. Once the process is complete, the R3 standby router becomes active and is used as the default gateway for hosts on LAN 1 and LAN 2. Restore the link to R1. Reconnect R1 to switch 1 with a copper straight-through cable. Okay, remember the LAN interface on R1 is gigabit 01. So use the copper straight-through cable to connect from gigabit 01 to gigabit 02 on the switch. Okay, and wait for the green indicator here. This orange should be green. Okay, execute the trace from PCB to the web server. You may need to repeat the trace to see the full path. Okay, green, now is green. Go to PCB, repeat the tracer, repeat the tracer. Okay, request timeout, repeat again. Now it's using R1. What path is used to reach the web server? At first, the trace fails. Okay, fails. Eventually, it begins using R1 as the gateway again, the default gateway. If the preempt command was not configured for the HSRP group on R1, would the results have been the same? No, R1 would not become the gateway again. The path through R3 would continue to be used. Okay, completion 100%. Thank you very much.